Okay, so hi everyone, Senan on this side, and in this video, I would be explaining you something very fundamental to computer science, which is bubble sort. So, I hope the spelling is correct. Anyways, what this bubble sorting actually does. So, given a list of elements, you are basically sorting the elements in an increasing or a decreasing order depending what your requirements are, right? And this is a very basic algorithm. So before you get into this video, I would like to warn you, video would be long. I would be doing each and every step. I would be making mistakes, and then as well as I would correct the mistakes, right? So you will have a whole thought process. You will have an experience of my whole thought process basically. So let's first of all understand what bubble sorting comes from. Where does it come from? Let's say you have a jar and it's filled with some liquid, let's say water. So what you do is assume there is a, let's use blue for representing water. Let's say there are air bubbles inside this jar or cup or glass, whatever this container is. Now my question to you is, assume this is placed on, right, let's say earth. Obviously we have gravity. So which bubble would you think would reach the surface first? And if you have even a slightest bit of idea about the Archimedes principle, your first guess would be that the bigger bubble would reach first. Why? The force applied, or the force is equal to the volume displaced, right? So the volume displaced in this bubble is more than this bubble, although you don't need physics to understand, but I assume this is the case. I could be wrong, but I assume this bigger bubble would reach the surface first when compared to this smaller bubble. Yep, so that is the same logic that we are actually going to use. Now let's look at an array. Let's just define a series of random elements. Let's start with 8, 7, 62, 47, minus 10, and let's choose another number, not too big, not too small. Let's say 12, right? And what I do is, since when programming, this would be given to you in a list or an array or a vector, but you get the point, right? So you have this input array, and what you do basically, you so there are basically iterations. So you first traverse this matrix once and find the biggest element and place it at this position. After doing that, you iterate this list again, but till this point, because the biggest element is already here. So now in the remaining list, you find the second largest element, and then which is 47, and you would place it here. Now in the third iteration, what you would do is find the third largest element and you would place it here. Again, you will find the fourth largest element and place it at this position, and finally you would find the fifth largest element and place it here. And by doing this, automatically the sixth largest element would be placed at the first position, assuming 1 based in indexing in this case. And that is the whole point. Now let's look at each iteration, right? So what do we do in the first iteration? I would basically, rather than destroying this original array, let's make a copy. We don't actually need to make a copy while programming. Now what I would do is, I'll take, or basically I would compare this and this element. Is 8 less than 7? So that is false, right? So what I would do is, I would take this list and I would erase 8 and 7 here, and I would write 7 and 8 here. Now we have done this and this comparison and did what we had to do, right? Now we go on to this and this element and we check if 8 is less than 62. So that is true, so we don't actually do anything, right? So in the next thing we would have the same array because 8 and 62 are in the correct order. Now what I would do is take this element and compare them. Is 62 less than 47? I don't think that is the case. So what I do is I do a swap. So after doing the swap, we would have something like this. So 47 goes here and 62 goes here. Then what I do, I just now since we are done with this comparison, I would compare these two elements and did I do a mistake? I compared this and the resulted array was this. Okay, so now I would compare this and this. So is 62 less than minus 10? So that is false. So I would basically do a swap. So where's my pen? Minus 10 and 62. Okay, great. Now again, okay, so copy, and before pasting it, let's see what we have to do. So now in the end we compare 62 and 12. So we see that 62 is not less than 12, so we have to do a swap. So I just paste this array, and what I do is I just erase 62 and 12 and just interchange them, 12 and 62. So we are done. Let's see what we did again. So this is iteration number 1. So what we did, we compared these two elements. They are in the wrong order, so we did a swap. Now we compared this element and this element. They are in the correct order, so we didn't swap. Then we compared this element and this element. Fine. So they are not in the correct order, so we do a swap. Now after this we compared this element and this element. So the order is not right, so again we do a swap. Then we compare this element and this element, we do a swap, right? So if you see how many times we did, 1 2 3 4 5 and 6, or so 1 comparison, 2 comparison, 3 comparison, 4 comparison and 5 comparison, and the final one is the output, right? This is the output, and we did 5 comparisons, and in the final, after the 5th comparison and swapping, we have this as the resultant array. Okay, so if you observe, starting from here, we got this element. Currently this is our max element. Now we moved one step ahead, our max element is here. Now we see this, we have a new max element, so we don't do anything. Now when we go one step ahead, so the max element is always pushed towards the right. Whatever the max you have currently seen till now, that is pushed towards the right. 62 is here, then it will be pushed here, right? So 62 is here. Now finally again 62 is again pushed to the right, and 62 is in the last position. So while doing this, we have our largest element in its correct position. I hope you get this, and this is what we are going to do. Now we have this at its correct position. Now we do the same thing, but in this case we assume that our given array is only this much, because 62 is in its correct position, right? So we just consider this remaining vector or array to solve. But for the sake of completion, we will actually take the whole array and we won't be disturbing that final 62. So, iteration number 2. So let's just paste this, and for the sake of understanding, I'll just change the color of 62 to, let's say, purple 62. So we know 62 is in its correct position, right? I previously told you this video would be a very long video, so keep that in mind, because we are doing each and every iteration as a computer would see. So now what I do is I compare these two elements. Are they in the correct order? I think so, yes. 7 is actually less than 8. So what I do is I just paste this array and we have this. So there is no change basically after comparison of these two elements. Now we compare these two elements, right? Is 8 less than 47, right? 8 less than 47. Again, that's true. We don't do anything, right? So we again have the same array. So you can consider each and every array as a state throughout its computation. You don't need to understand what I just said, but if you do, that's great. Now again, what I would do is I compare these two elements, and in this case we know that 47 is greater than -10, so we need to perform a swap, and that is what I would be going to do. Again, I would paste this, place this here, and I'll just interchange the values. This would be -10 and this would be 47. Okay, this is good. Now I compare these two elements, and obviously 47 is less than 12 is incorrect, so we again have to perform a swap. So copy and paste, right? And in this we would do a swap, 12 and 47. Now again, now we are at 7. Let's just look at what we did. So we started at 7. We saw that this is the current largest, so we did not do anything. We compared this with 8, so 8 is our new largest. We don't do anything. We go ahead to 47. 47 is our new largest, so we are basically at this position, 7, 8 and 47. Now when I saw -10, I know this is not the largest because I have a number which is larger than this, so I push this element towards the right. So 47 is here. Now again I encounter a 12 and I see that I have a bigger number already that I have seen before. I will do a swap with this. So 12 is here, 47 is here, and by the end of this iteration, the second largest element is in its correct position. So second largest element at its correct position. I hope this makes sense. Okay, finally, or not finally, we have more iterations to go. Iteration number 3. Now I'll take this, I'll just copy this, copy and paste, and just for the sake of understanding, I'll change the color of 47 to purple. 47. So now we know 47 and 62 are in its correct position. So what I do is I check these two elements, are they in the correct position, and the answer to that is yes. So I'll just keep it as it is. Now I compare 8 and -10. Are they in the correct order? No, right? So 7 and 8 are in the correct order, not position. So in this case we have to perform a swap. So what I do is I just paste this array and just do a swap. So 8 goes here and -10 goes here. Now what I do is I compare these two elements, right? Are they in the correct order? Is 8 less than 12? Again, that is true. We don't do anything. We keep the same array as it is. Okay, so basically the wrong array. Okay, let me just, okay, so this is 47. So 47, 47. And yeah, what were we checking? First we checked this and this, then we checked this and this. Now we are checking this and this. So these are in its correct position. So in the okay, after this, copy and paste. So we know 12 is in its correct position. So we basically we saw 7 is the largest till now. Then we went on to see 8 is again the largest till now. And then we saw minus 10, and we know that we have already seen an element which is greater than the minus 10. So we have to push this 8 towards the right. So we are here again. We check 8 and 12. So 8 is less than 12. So we don't do anything. We just keep the array as it is. And by this time we have our third largest element at its correct position. Okay, fine. So what I do is I go on to iteration 4, and in this case what I do is I take this okay, so I need to undo. So I'll take this array, I'll create a copy, and I'll just press paste, and for understanding make this 12 in purple. So we know, sorry, not 17 but 12. So we know we have these 3 elements in their correct position. Now again the same thing, we do a comparison. Is 7 less than minus 10? That is false. So what I do is I take the same array and I would basically perform a swap. So in that case minus 10 goes here and 7 goes here. Now in the next iteration I would check if this and this is in its correct order, not position but order. So 7 is less than 8, so they are in correct position. So I can just take this and copy and then paste. So this is our final answer. So we see the top, the four largest element are in their correct position. Now finally in this, again I don't want to write the fourth largest element is this thing. Same thing for the fourth one, right? So now I go to iteration number what? Iteration 5. And what I do is I take this, I make a copy and I paste this, and yeah. Now if you see what, for sake of understanding, make this 8 with purple. So we know these 4 elements are in their correct position. Now what we do is basically compare these two. Are they at their correct position? I would say yes. Minus 10 is less than 7. And for the sake of understanding, let's assume if 7 was here, minus 10 was here, we would then do a swap. But that is not the case, so we are done. So finally, after the end of iteration 5, what we would have is this array. And now if you see, if I go to iteration 6, I would only have a single element, right? I would only have a single element, so I cannot actually do some sort of comparison with any other element because every other element is in its correct position. So by the end of iteration 5, we have our array as sorted, and for the sake of completion I would write this and say finally this is -10, this is 7. So this is our sorted array. I know the color is basically not correct, so -10, right? So after this, what we did was to have the sorted array given this okay, so there are a lot of iterations given this random array that I thought about. Okay, so you see the biggest bubble is getting pushed towards the right at each iteration. So that is what is the whole idea behind bubble sort, right? Now let's write the code of exactly how you would implement this, and we'll see what to do. So how many iterations did we get, or how many iterations did we do? So for a size of 6 elements we did iteration 1, 2, 3, 4, 5, 5. So for n equal to 6 we had 5 outer iterations. Fine. And how many inner iterations did we do? So when iteration is 4 we did so number of comparisons, so we did 2 comparisons in this case, we did 1 comparison in this case, we did 3 comparisons in this case, we did how many, 1 2 3 4, so we did 4 comparisons in this case. Now, iteration 2 4 comparison, iteration 1 5 comparisons, right? So iteration 1 4 comparisons, iteration 2 3 comparison, iteration 3 2 comparisons, iteration 2 okay, so iteration 4 1 comparisons. Am I right, or have I shifted one value? Okay, so I have shifted. So for iteration 5 I have 1 comparison, 2 here, 3 here, 4 here, and 5 here, 5 comparisons. So we need to find a relation between this. This is what? This is, let's say, I, the outer iteration, and this is j, the inner iterations. Okay, so first of all let's write the code, right? Let's call this function bubble sort, and input is our array. So I know I need to have a for loop outside and some sort of inner for loop for the comparison and swapping, right? And I just return the array itself, or we don't return the array if assuming it's passed by reference. Okay, so first of all we need to find the comparison the relation between I and j. So obviously whenever we start comparing, we started from j is equal to 0 and we went till what? J is equal to let's go to the very first iteration. We started j from this position and we went till what? J is, this is 0th index, so first, second, third, 4th and 5th. We went to n minus 2th index, right? J goes to 0 to n minus 2th index, or n minus 1 minus iteration. So that is the logic I would use. So rather than I going from 0 or from 1 to n minus 1, I would say I goes from n minus 1, or let's say I goes from 1 to n minus 1, right? And for j, I is equal to 1 to n minus 1, and let's say j goes from 0 to n minus I minus 1. Now, okay, so I'm just currently guessing these values, and this is just an approximate guess that I'm making. Okay, we'll look properly in the later part of this video. And what I do is, if array of j is greater than array of j plus 1, what we do is swap array of j and array of j plus 1. That is what I am going to do. And basically this is the code that I have to go through. Now let's just verify if the iterations are correct or not. Okay, so since we have, for size n element, we have 5 iterations, right? So for size n equal to 6, we have 5 iterations, outer iterations for the I. So basically n minus 1 iterations. So in this code, we are going from I equal to 1 to n minus 1, and also most importantly, n is equal to array dot length or size, or whatever the programming language provides as a size. If it is C, the n would be provided as an argument. Anyways, okay, so we know that this outer loop is correct. Now let's see the inner loop. How long does it go? So this n minus 1 is inclusive, not exclusive, right? Similarly, let's go at iteration 1 and see. So let's say j starts at 0, and how long does the j go? J goes till this position. So this is what position? This is the 4th position, 0 based indexing, 0 1 2 3 4 5. J goes till here, and if I write j, this I can write as n minus 1 minus I, right? So iteration is I is this iteration value, and n is the size of this array, that is 6 minus 1, which is 5, minus 1, which is 4. So we go till this position, j goes till here, so that we can perform a comparison at this location. At iteration 2, our j starts from here, j is equal to 0, 0 1 2 3 4. We assume that we have an array till this length only, and our j should go from 0 1 2 and 3. So this would be n minus 1 minus I. So n is 6 minus 1, right, which is 5, and I is 2 minus 2. So this is 3. So I think this is working well. So this is valid. You could check for 3 4 and 5, and I assume this would work. So this is our function for writing the bubble sort. Okay, so we declared the size of n, and what we did, we initialized the iteration. So I denotes the iteration. It starts from 1 and it goes till n minus 1 iterations. So what I do, I start, so everything is 0 based, so I check j and j plus 1, so two adjacent elements, and if the element at j is less than element at j plus 1, I do a swap. Or if element at j is greater than element at j plus 1, we do a swap. Otherwise we don't do anything. So this is what we are actually trying to do. So j goes from 0 to n minus I minus 1, and this number is inclusive, so j would attain a value. n minus I minus 1. Sometimes if you write this in Python using the range function, so range, let's say 1 to 100, so this is not inclusive, this is inclusive, this is exclusive. So 1 is included but 100 is not included. I'm saying both are included. So that is about bubble sort. I know this is a very long video. I hope I was able to teach you something. This is a very fundamental thing about computer science, sorting. Hopefully in the next video I would go over selection sort or insertion sort, and after doing the big O of n square complexity sorting algorithms, I would go to n log n time complexity sorting algorithm. Again, yeah, I should have discussed the time complexity, so let's just do this. So for how many iterations are we having, right? So we are having n minus 1 iterations depending upon n, right? N is the size of input size. So the outer for loop is running for n minus 1 time. And how many comparisons are we having? That is also proportional to the size of the remaining array, right? Basically there are 2 for loops. Assume this comparison goes till the end, right? Not 0, it goes till n minus 1, although there won't be any swapping in that case, but let's just assume this, rather than going to n minus I minus 1, this goes till n minus 1. So in the worst case, this would be more n minus 1 comparisons. So if you multiply this, you will get an order of n square algorithm. This is the best case, this is the worst case. So regardless of whatever you do a comparison, and since swapping is a constant time operation, it's useless. So this is big O of n square, this is big omega of n square, and so this is big theta of n square as well, this algorithm. Even if you have a sorted array, previously you have to do all comparisons and you have to do all checks regardless if the array is sorted or not, which is not the case in insertion sort. So in the best case, what you can have is a linear time complexity if the array is already sorted. So that is what this video was all about. Hope you enjoyed this, hope you learned something. Anyways, if you want, you can basically like, share. Subscription is not important as long as you are sharing this video with someone who actually needs it or who could possibly use these kind of videos. If you share this, subscription is basically negligible. So what is important is not even like, I would say, if you just, my only request to you is just share, and share it with anyone who requires this, not to anyone, not to someone who doesn't even know about anything about computer science. Share it with someone who you think would actually benefit from these videos. So thank you, this was the video, hope you enjoyed this, and bye.